So imagine, if cameras can see people. Specifically, like longer term where I want to go with this is when, phones can see people. So we've developed a thing called bodySLAM that takes 2D video and generates 3D humans. I've worked on a lot of different AI systems, and what I love about bodySLAM is that it's really easy to explain at that level. Of course, it's really hard. So obviously the name is a very bad pun for SLAM, and I'm aware for the computer vision people that it's actually not SLAM, but it sticks in your head and you'll never forget it. So that's what we're going to talk about today. So, why do this again, right? We are a company, we're a startup, wrnch in Montreal, and I'm a serial entrepreneur. This is my third startup. And so what really excites us, I think, from an application perspective, is social video and social augmented reality, if you will. So if you're familiar with Snapchat and their filters, that inspired me a lot. I have teenage daughters, and so I watch them on Snapchat. I see how they consume things, and I was really inspired. If just doing a filter on a face at this degree can be interesting, what if we could do the entire body? What kind of cool things? And so we can just see some examples of this, and I can play a little bit of footage here. Let's see here. Part of the fun is for us. Oh, did it not go? Oh, all right. Is it going? That screen, there we go. So, if we can, the idea is if we can see people in the video, then we can do all kinds of things. So the guy from Comcast yesterday, previous talk, I think that's building on a larger trend of like, once we can know what's in video, then what can we do? So I come again from a game and a visual effects perspective. So our use case is really say, hey, if you can understand a video and understand where the people are, then you could you could use a game engine to do all the magic that a visual effects artist does. And so that's just some footage of the Dallas Mavericks. I think it's Dirk's 30,000th point. And so, again, to do that kind of little piece of footage, in the old days, you have to record the footage and send it to a special effects artist. He goes through, uses After Effects, adds some stuff, and probably now, the turnaround time is like a couple hours. So we can do this automatically, and what's really fun is everybody can do this automatically. So I'll get rid of this. Other applications of when we can start to understand where humans are in video feeds, what can you do? A lot of VR is here. So an application we're working on is, you see all the VR demos out in the exhibit hall. And so the nice thing about VR is immersive, but the problem is it's very restricted, right? Like, we just see these people, they're sitting there like this, and you're like, what's going on? And so people are doing, they'll put like a companion TV there, and so you see what the player sees. But that doesn't really make sense, right? What you really want to see is, if I see someone playing, I want to actually see that person in that world. So the obvious way to solve that is a green screen. But green screens are expensive to set up. There's not much, imagine if everyone here in this exhibit hall had to set up a green screen. That just wouldn't make sense. So the negative of, if you know where the people are, then you automatically know what the background is. And so you can basically build a virtual green screen. So find the people and extract the background. Augmented reality gaming, again, if you know where the people are, you can do all kinds of things through the phone. And also, some of the stuff we're applying is inside-out tracking. So when people are wearing the goggles, right, and let's say it's in a room about this size, you're wearing the goggles, and we're playing a location-based game, how do I, in a weird sense, if everyone has goggles on, we want to be in the synthetic world, but we actually want to be in the real world too. I want to be able to see you sitting there at your chair drinking, and so how do we know where the hands are? So our stuff can basically see where the body is and then feed that into the virtual reality system. And then, health and wellness. Basically, understanding human motion is sort of fundamental to a lot of different things. So sports analytics, and this I think really builds on the Comcast thing of like, we're talking to people about, if we can understand what's going on in the video, then we can allow other people to build on top to build interesting metadata, right? Of like, we can track the players. We can tell you how fast they're, you can, once you know who they are and where they're going, you can build up on that, how fast are people, moving across the field, so on and so forth. So it's sort of like a base technology that opens up a lot of possibilities. And really, this shows video is everywhere. And then I think the last, and this is where all of these AI technologies are coming together, right? People are building virtual assistants, and they're starting to have eyes. And so understanding where the human is in that is fundamental. One of the visions we have is that I would say in the near future, I'll be able to just take a picture. I'll actually take a picture and say, Siri, how many people are in the room? And this is why. This is sort of an application of this. So what are we doing? So it's a deep learning API. And it's really, you put 2D video in. It's as simple as that. There are some fidelity of like the scale of the resolution that you're working on, things like that. And then out come human features. Right now we're tracking 21 joints, including the eyes and the ears. The skeletons, we can produce 2D skeletons or 3D skeletons. Different use cases have different needs. There's a cost to 3D, and again, we're taking this from just ordinary RGB. And then the fun part is you just do the negative, and then you get a virtual green screen. And so the platforms we're running on CUDA, that was the first platform. Although we are moving this to mobile devices. So we're writing our own framework to load cafe models that will basically underneath, it will run on CUDA, it runs on Metal performance shaders on iOS, and then good old OpenCL on Android. So the tech stack is an interesting mashup of deep learning and game tech, and I would encourage computer vision people to reach out to game developers and people with game technology backgrounds, because I think especially when you're looking at augmented reality, what is augmented reality? To me, it's the perfect synthesis of the real and the synthetic, right? So the real, here we are, and you're going to use computer vision to understand that world, but in order to add synthetic, there's nothing better than a game engine because it's real time, and that's where the magic becomes. So we have a 100-layer plus convolutional neural network in Café. I'll talk a little bit about the training data in a second, and then we've got another chunk that does the tracking, right? And I'll talk about that. You can see on the slides, you can see, so you can take people in. We first generate the two-dimensional skeletons of everyone. Then from that, we segment each individual person, and then we throw that through another neural net to get the 3D person out of that. Then from that 3D data, we really visualize that as like traditional mocap in the sense of if you had like a large mocap system. So it's going to be noisy, it's going to have problems, and there's going to be occlusion, right? Sometimes I'm going to get a joint, and sometimes I'll get all the joints. And so then we map that to a game engine where we have an inverse kinematic system, and that gets us all the smoothing and everything. And I think that's a really important way to look at this problem. And again, this slide's a slight redundancy. So here's a higher level or a little lower level picture of this. You can see what we're doing is through the neural nets, we're finding all the joints of everybody. Then from the joints, then we glue the people together effectively. And then once we know where each person is, then we run it through to get individual 3D people. So the training pipeline, I think, is very novel. Now we're a startup in Montreal, so we're 13 people, not a very big team. We don't have access to the large data sets that people. So we're very grateful for the COCO database because that's like sort of out there for everyone to use. But it's not that big of a database, and so what we've done internally is we've taken that, then we actually took a Kinect, and we use that as our own sort of cheap and cheerful motion capture system. And I think the theme of all of this is we were able to build this all with game quality hardware. Like our Our training system is a gaming rig. It's a $10,000 gaming rig with 4 GPUs in it, but that's how we trained everything. Just with our cooling system's not as fancy as what Jensen was showing. We just bought like a gamer rig that had ultra cooling, and so we use Connect, and we generated our own data sets with that. And then I think the most novel is we did synthetic data. So my background in a previous life, I built a virtual human system for retail in the late 90s. And I've been doing crowd simulation, all kinds of things. So the idea was, we need lots of people, like it's all about data, right? So how do you get as much data as possible? So Coco's there, great, take it. Connect, it's cheap and cheerful, but it doesn't really scale up, right? So what we did is we generated a whole bunch of virtual humans, we're using the Unity game engine. We generated a whole bunch of virtual humans. We add a whole bunch of different animations to them. So we put them in different poses. We have different backgrounds. The very psychedelic backgrounds, our scientists tell us that that's helpful for training. I don't honestly get it. I was expecting more photorealistic backgrounds would be helpful for training, but they're the experts, so that's sort of an interesting takeaway. And so we merge all that together, and I think that's going to be a theme you're going to see a lot more, and I would really encourage, people for their data sets use game engines. It's just, I think the Isaac the robot simulator is sort of the ultimate version of that, if you will, that we saw this morning, but this is our version of that. And that's our training pipeline. And so once we have all the data, all right, once we know where the people's limbs are and stuff, then we move to the augmented reality part of it, where we say, hey, we know the body parts, and let's add cool visual effects to them. So I'll just show you a simple video. There we go. So again, this is Mark Cuban's an investor in our company, so he was generous enough to let me come to Dallas, and we were working in the control room. So we had one of these big MSI boxes in the control room, and we were taking in highlights and then automatically annotating them and shooting them up to the Jumbotron, which is pretty cool, and things like this. So I think this is going to be just normal part of, and then that kid goes up like that. But I think this is going to become more and more normal, right? It's like the Comcasts of the world and stuff will be like the highlight reels will have just a lot more of this. Oh.
My first pro paycheck.
Okay.
I bought.
Stop that.
First thing I bought, my first pro paycheck, probably my truck, my mama car. It's a long time ago, getting old.
I think another interesting trend that we think is going to really accelerate is this sort of notion of mashup culture, right? Of like people are making videos, especially in Asia, they're videos, and then people make videos on top of the videos and they annotate it and stuff. So this is this Korean pop group that we annotated. And then, I mean, it's a silly example, but it just shows how robust the tracking is and stuff. We're tracking multiple people. Very occluded. All right. So, like I said, this is a screenshot. We're using Unity. It's a great game engine. I also love the Unreal 4 engine, a lot of experience, but for a new team, it's really easy to get up and running. So this is how we generated synthetic data for these characters. And we also built the app. So I'm going to show you, in the time I've got left, I'll show you the app running live right here. So let's do that. Yeah, so let's see, 8. So, oh, look at this, it's working. So we'll see if this works. Maybe I'll get a volunteer. Somebody come over here. Who wants to? All right, come on. It's a demo, so it's going to crash the first time anyways, but we know that, right? So just stand there. That's perfect. Looks good. Let's be gentle and just go with a simple simple pose first, and then we'll get pathological, right? So there we go. We see his skeleton. That's pretty cool. You can look at yourself now. Sorry. And then, so what's fun is, right, we can add different effects, like your hands. Because it's 3D, we can give a suit. well, maybe we'll step it up and then we can add like different, extract backgrounds or money. So, you know, lots of fun. And then like drive emojis, that's just me. It's just sort of a dumb Snapchat kind of thing. So why don't we try something? Let's go for it and just, I know it's going to fail, but let's try it. When I say 3, 2, 1, go, just a gentle kind of movement pose, but let's try it. So 3, 2, 1, go. Go. And you can spin. Yeah, you can walk around. Okay, there you go. Be free. That's right. There you go. All right. Yep. This. What I love about doing this kind of stuff, testing it on with engineers, is they go pathological, right? And so it's thinking. So it's shooting up into the cloud right now. So we're on AWS, and let's see how we did. Okay. Oh, let's see. We got some other people. So it's So here it is, and then so we got fire, the background. So now where it gets fun is like we'll turn it off. And and I think this is the future of cameras. Phones are just going to have this stuff built in, right? And lots of kind of fun like that, right? So, anyways, I mean, it's very hard work, but thank you very much. So in the future, so where we're at as a company is bodySLAM works. It's in the cloud. The API is there. We're working with first customers. We'd love to hear about your use cases, see how, it doesn't have to be as silly as this. It could be as concrete as theme parks who really want to understand and have better understanding of what guests are doing, things like that. Obviously, we're optimizing. Very excited by the Tensor RT. I think that's going to help all of us. We're moving it into mobile support, like I was saying. That's actually what we shot, yeah. So that's and then higher fidelity, right? Because more is more. We're tracking 21 joints. Obviously, like to track, a bone here, this bone here, things like that. You can always have more, but yeah, I just shot that on the floor, and I, put a little suit on. The lighting's not great. So yeah, so really interested in your use cases and seeing how we can work together. That's part of the team. Thank you very much.
I have to say, doing a live demo is the first one I've ever seen at GTC, and it worked. But you knew it would, right?
No, but it did. Yay!
So well done, Paul.
Thank you.
So we have 5 minutes. You actually finished a minute early, which has never been done. In addition to doing a live demo, so questions in the back here. Okay.
Are you capturing any movement data on the back end?
Pardon me?
Are you capturing any movement data at all
No.
on the back end for movement analytics?
What do you mean by movement? Are we capturing movement data? Sorry.
So for example, if I'm looking at this and I'd like to apply this to physical therapy and I'd like to see the range of motion.
Ah, okay. So in the back end, what we're spitting back to you is literally, and excuse me because I speak extreme game, we're spitting you back a 3-dimensional skeleton and at every frame. So you would have to extract on top of that. In the future, depending on if that becomes more and more of like a common, that's how APIs evolve, right? If that becomes more and more of a common case, then we'll throw it in there. But right now, yeah.
A quick question. So how does this work if there's occlusion, like part of the body frame is blocked and?
Well, you see it there. We've got a fair bit of occlusion. Happy to just throw the dice, and we can. If you've got a pathological use case, come on up and we'll try it. I mean, as simple as that. It works. So how it works is why it's so robust is we identify joints, right, and then we glue the joints. So here, you only see this part's occluded, right? So that's how we're pretty successful. I mean, this sometimes works, sometimes doesn't work, but it's pretty robust. And that's very important because people are not, people are in the real world, but also people are with people. And so that's how we handle occlusion.
I invite the pathological cases to be outside afterwards,
okay,
and you can go wild
sorry.
there. Here we go. Excuse me, Hardy. Of course, you had to be as far as possible. There we go. I'll stay here.
Hi. So I want to know how it scales this system with higher resolution images or higher resolution videos.
Right. So it scales in the sense that more information in is going to be more expensive. So it's pretty much a function of the resolution. So if you go up fourfold, that's how your processing is going to go up. Where it gets interesting is the scaling that's really important is the size of the people. If they're too small for the resolution that you're inferencing on, you just simply can't see them. And so that's one place where you have to sort of fine tune to say, if I've got like a 2K video and the people are this high, then you're going to want to like run at a higher resolution. But if the people are relatively large in the screen, then you can downscale like crazy. But it does scale constant across all the people in it. So in the sense of if there's 100 people in the scene or 5, it doesn't matter on the 2D side.
Hi, I was wondering, have you compared your results, I mean the joint angles, with the state-of-the-art motion capture systems like Vicons? I'm talking because I'm in the field of biomechanics, and can it be applied to biomechanics when the joint angles are important?
Right. We haven't, in the sense that we're sort of, because that's very difficult, right? Those hundreds of thousands of dollars of equipment, there's a reason for all that. So that's why we sort of targeted first entertainment applications that could have a lower fidelity. That being said, I think one of the experiments we're doing right now is to go from RGB to RGBD and just see what that gives us. I think when we add the D from the sensor perspective, I think we're going to get pretty good, but I think it's not our expectation that we're going to surpass those people in the next 6 months. But that being said, probably for one person, like if you were working with somebody close, a single person and a stable camera, I think it's worth investigating.
Another question back here. Hello, for game developers, do you plan on releasing a Unity plugin so they could use this technology to help out?
So how we want to work with game developers initially, so I've done 2 middleware companies, so in the past, is we want to do more co-productions in the sense. We think we bring something really, really unique to the table, and so work like a technology partner. So we won't go mass market, it'll be more like choose a couple partners to work with and work together.
Time for one more.
In examples like your the sports with the basketball teams and doing sports analytics, can you feed multiple cameras in that are possibly gen-locked and try to get that more fidelity from more sources?
Like sensor fusion, if you will. Yeah. Have thought about it. We just haven't had a practical use case for that. But it should, especially if those cameras are locked, then you have so much information. So I think it will work very well, but we haven't done it.